Hello, in this video I'm going to be going over a momentum question. So this one involves a collision where there's two separate people that have different initial momentum and they collide together and have a shared momentum at the end. So let's get started. The question reads, finally, when the coronavirus pandemic is over, you and your grandma run towards each other for a great big hug. Your mass is 68 kilograms traveling at 4.2 meters per second, and your grandma's mass is 50 kilograms and she's traveling at 1.9 meters per second. When you finally meet, what is your shared velocity? Okay, so let's start off by drawing a diagram of what's happening. So if this is you over here and you're running this way towards your grandma, which is over here, and she has her cane and she's running towards you over here. And when you finally meet and give each other a great big hug, you look something like this, something like that. And then you do have a final velocity. And that's what we're trying to find, what this VF is when you are together. So this is the initial part, and this is the final part. So for all these momentum type collision questions, you want to find the relationship between the initial momentum of each object and the final momentum of each object. This will give you a nice mathematical representation of what's really happening with the momentum. So let's start by doing that. So we do note that the total change in momentum is equal to 0, right? And this is equal to the final momentum minus the initial momentum. So that means we can just move 1 to the other side. So we have PI is equal to PF. So this represents the total momentum initially, and this is a total momentum finally. So initially there's two people that are moving. So there's two separate momentums, one for each person. So we can denote that as PCI for the grandchild and PGI for the grandma. And the final momentum, there's only one because when they're together, they're considered as one object. So we can just leave that as PF. So if we further break this down, we know that momentum is equal to M times V. We can write PCI as being MC times VIC for the initial velocity of the grandchild, and PGI, we can do the same thing. So mg and then VIG. And this is going to be equal to m, and then this is going to be the mass of both of them combined. So C plus G, and your VF will just be the VF of both of them. So in this question, what we're trying to do is solve for this value here. So this is the equation that shows a relationship between the initial momentum and the final momentum. So this is going to be different for different scenarios. And you want to make sure this is set up properly. So let's go ahead and solve for the shared velocity, which is this velocity over here, VF. So all we need to do is just divide this value over to this side, and we would be able to find our final velocity. So I'll do that. So you get VF is equal to so that's what you get there. So since we have all of these values given to us, all we need to do is plug them in and solve for VF. So let's go ahead and do that. So this becomes MC is 68 kilograms times 4.2 meters per second plus mg, which is 50 kilograms. And her velocity is going to be in the opposite direction of the grandchild's velocity. So we can just put it as a negative value. So that's 1.9 meters per second all over MC, which is going to be 68 kilograms plus 50 kilograms. So at the end, they're together, so their mass is just added. So multiplying those out, I get 285.6 kilogram meters per second plus negative 95 kilogram meters per second all over 118 kilograms. And I get 190.6 kilogram meters per second all over 118 kilograms. And that final value is equal to 1.6 meters per second. And that is your final answer for VF. So the shared velocity is 1.6 meters per second in the direction that the grandchild is moving. Okay, so that's how you do this question. I hope it helped. If you have any questions or comments or would like me to do any other physics questions, please leave them in the comments below. Thank you.